The directions ask us to simplify. So we're not solving. We're not going to get a final answer that says like x equals 3. We're going to simplify as far as possible. When I see this, I'm going to start by dividing by 5, and I get 1x squared minus 1. And this needs to be a trigger. I see these are both perfect squares. I have subtraction and a square. This breaks into x plus 1 and x minus 1. Whenever you have two groups that are separated by addition or subtraction, you always have to find the LCM every single time. So how do you find the LCM here? Okay, so this is what I have on the right. This is what I have on the left. So I know I need to have 5 as one group. I need to have an x plus 1. And I need to have an x minus 1. Now, the left-hand side has all 3. I don't have to do anything to the left-hand side. The right-hand side, it's missing a 5. Whatever I do to the bottom, I need to do to the top. It's missing an x minus 1. Now I'm checking 5, x plus 1, x minus 1, 5, x plus 1, x minus 1. So what do I do? Just as a little reminder, we don't cancel out the bottoms. I did see that walking around. That's only when you have an equal sign and you're solving for x. So on top, I have 3 all by itself. Then there's a subtraction sign. 1 times 5 is 5, and x minus 1. So I'm only going to work with the numerator to start with. I'm going to distribute here to have 3 minus 5x plus 5. And that's going to be negative 5x plus 8, all over an LCM of 5, x plus 1, and x minus 1. That would be option D. This is problem number 4. And the difference between problem 1 and problem 4, there's a distinctive difference. Yes, I have two groups and they're separated by an operation, but the operation is multiplying, so I don't have to worry about an LCM. When I'm working with multiplying, I literally am able to think of this. There's one group, this C is a group by itself, then D is a group by itself, that's a group, and that's a group. So they're all like little single groups, right, except for these two. So I'm going to start on the bottom. Is there any single C's on top? Nope. This is not a single C. This is not a single C. It's with a group. Is there any single D's on top? So I know in our mind we think they cancel out, they disappear. Remember, they really are going to divide and equal 1. Is there any single 2's on top? Nope. Is there any single C's on top? So this is what I have. I have C minus D, C plus D, all over. Okay, there's a 2, and then there's 2 C's, C squared. This would be. So this problem is going to be like number 1. This is problem 2, and Stephanie asked a great question, like, how do I get started here? Well, when I have two groups that are separated by addition or subtraction, I do need to figure out the LCM before I can get started. So how do you figure out? Well, if there's a possibility of factoring, we want to do that first. What multiplies to equal negative 14 and combines to equal negative 5? That would be a negative 7 and a positive 2. So these are equivalent forms. And so when I look here, I have the two groups. Over here, I have one group. So the LCM is x minus 7 and x plus 2. Right now, the left-hand side has everything I need. The right-hand side is missing an x plus 2. Whatever I attach to the bottom, I must also attach onto the top. So in this case, I would have 10 plus 2x plus 4. That's equivalent to 2x plus 14. So it could be written like that, or you also need to recognize it may be written like this. Both are equivalent. What goes on the bottom? The LCM. The LCM goes on the bottom. Each one would be correct. They're just equivalent forms. We're going to flip over and do this one. Now, this is problem number 5. Problem number 5 is kind of like a puzzle, figuring out a puzzle. It's a little more difficult. So I recognize that each one of the 3 groups is divisible by 4, and each one has x's. Now, what's the most x's I can take from each group? 2. So I'm going to take out a 4x on top and bottom. So 4 times 1 is 4. Give me 1 second. 4 times 1 is 4. I need a total of 5 x's, so I attach 3 more. 4 times 1 is 4. I need 3 x's. I attach 1 more. 4 times 3 is 12. I need 2 x's. I already have them. These don't just disappear. Remember, they're really going to reduce down to a 1. I find this option. Okay, please look right now. We got to speed up our pace. Let's look at 3 and 6. 3 and 6 go. What?
On this thing sticking up?
Yeah, that's fine. Uh-huh. So there's several ways you can do number 3. Some of you, myself included, would probably first reduce the 6, the 2, the 5, and the 10. Others may choose to use this, where you're going to go, okay, I know I want to take 6 times 5 and divide it by 2 times 3. I'm going to get an answer, turn it back into a fraction. I'm going to, oops, sorry, I just wrote that down wrong. Let's try this again. Take 5 times 6 divided by 2 times 3. What am I doing wrong? Okay. 5 times 6 divided by 2 times 10. How about that? And then I need to turn it back into a fraction to get 3/2. Again, I personally would do mental math, and I think that's quicker. It's up to you. I'm counting the number of x's on top. I have 5. The number of y's on top, I have 3. The number of x's on the bottom is 1. The number of y's on the bottom is 4. 5 subtract 1 is 4. Highest one is on top. 4 subtract 3 is 1. Highest one is on the bottom. Done. Flipping around to number 6. I do not care that you know, oh, this is called factoring by grouping. I do want you to know how to work with it. In these first 2 terms, I can factor out an x squared, and I'm left with x plus 3. I'm going to take this and copy and paste it in back and put a really light question mark. What times x is negative 2x? And is that same number times 3 negative 6 it is. So what do I do with this? Well, to write this correctly, they both have an x plus 3. In front of the first is an x squared. In front of the second is a minus 2. And on the bottom was an x plus 3. So this group of x plus 3 and this group of x plus 3 on top, because only multiplying is occurring, one group times another group, I'm able to simplify, and I'm left with just x squared subtract 2 on top.